Hello students, in today's class we are going to learn about a concept called functions. So far what we learned about Cartesian product of two sets and then what is meant by a relation. What is meant by a relation? Relation is a subset of Cartesian product. It is a subset of Cartesian product and it is defined from one set to the other set. That's what we learned in the previous class, right? So today's class we are going to learn about functions. What is meant by a function? A relation is called a function. So we are defining function from a relation. First of all, it should be a relation. A relation is called a function if every element of set A has one and only image in B. We have seen few examples in the concept of relation where one element of A can have many elements, images in B. We have seen few examples, right? Those relations are not a function. Each and every element in A, in the sense each and every element in the domain, we will call this as domain and this as codomain. Hope you remember. So every element in the domain should have a single image in the codomain. Single image in the codomain. Right? Then only that relation is called a function. If f is a function, we will denote like this. F is a function from A to B. Then how we can denote this? The ordered pair A comma B belongs to F. The ordered pair A comma B belongs to F such that f of A equal to B. Whatever relation is defined under this function, then if you apply it on A, then that answer will be in the set B. Right? So we will call it as f of A equals to B, and this B is the image of A under F. This B is the image of A under F, and this A is called the pre-image of B under F. This definition and all I told you in last class while defining the concept of relation. What is meant by image and what is meant by pre-image. Yes, hope you remember. Now let us see one example to get a better clarity about functions. Now let us examine this example. Now f is a function from A to B such that f of x is defined as x square where x belongs to the set A, right? So what is the function? The square of that particular number. What are all the elements are there in set A? 1 to 5 and B 1, 4, 9, 16. Now let us represent it in arrow diagram. In set A we have 1, 2, 3, 4, 5. In set B we have 1, 4, 9 and 16. Now the mapping is from that element to its square elements. So 1 should be mapped to 1, 2 should be mapped to 4, 3 should be mapped to 19 and 4 should be mapped to 16. That's it, right? You have to put arrow marks here. Then only we know which is domain and which is codomain. Now we will call set A as your domain and set B as your codomain, and these are all called images and these are all called pre-images, and we know there is another name for all these things which is range. Yes, these are all images and these are all pre-images, right? Now listen, let us check whether is this a function or not. We know this is a relation. Some relation is defined from set A to set B. Now is this relation a function or not? What is the definition of a function? Says each and every element in the domain should have only one image in B. It should not have more than one image. If you take the element 1, it has only one image. If you take the element 2, it has only one image. Likewise, everything has only one image. But if you see another issue over here, there is another element called 5 which does not have any image in B. Which does not have any image in B. Then in this case also this is not a function. In this case also this is not a function. So the definition of a function says every element, understand, every element in set A should have single image in set B. Even if a element is left out without any images also, the particular relation is not a function. So every element should be mapped to some element or the other in set B, right? Now let us give me some other example for a element in A having many images in B. Now check out this example. The function f is from a to b such that f of x is equals to square root of x where x belongs to a. Now the function is defined in such a way each element in a should be mapped to its square root. What is the square root of 1? It can be minus 1 or it can be plus 1, plus or minus 1. So 1 can be mapped to minus 1. What is the square root of 4? It can be plus 2 or it can be minus 2. So it will be mapped to these two elements. What is square root of 9? Plus or minus 3. So 1 is mapped to minus 1, 4 is mapped to 2 and minus 2, 9 is mapped to 3 and minus 3, and 16 don't have any image in B. So this such a kind of relation is also not a function. See, one element in A is mapped to two elements in B. One element in A is mapped to two elements in B. This is also not a function, right? So a function, how we can define a function? A relation f from A to B is called a function if every element, each and every element in A has a single image in B, right? Whereas the other way is possible. For example, two elements in B can be mapped to, single element in B can be mapped to two different elements in A. That can be possible, right? For example, suppose if you have a mapping like this, an element in B is mapped to two different elements in A, then this is a function. This is a function only. A image can have two different pre-images, but a pre-image cannot have two different image. Hope you understood. Yes, I am repeating. So when a relation is called a function if every element, understand, if every element of set A has one and only image in B, which means the set A should not leave any element, as well as it should not have two images. Single mapping only should be there and every element should be mapped. Such a kind of function is only called a, such a kind of relation is only called a function, right? If it has two if it has two images, and then it is also called not a function. And if a image has two pre-images, it can have, it is a function only, right? Let me give you a simple clue to remember. See, your left palm is not a function, but your right palm is a function. What is your left palm? See, here one point diverges to 5 different things, which means this is your domain and this is your codomain. So one element in your domain maps to 5 different elements in your codomain. That is not possible. That is not a function. Whereas from a domain, and this is codomain, 5 elements from your domain can be mapped to a single element in a codomain. Then this is an example of a function. Hope you can remember in a better way. Your right palm is a function, your left palm is not a function. Single point maps to different elements, which is not a function, where different points can map to a single element. This is an example of a function. Okay, so which are all the things you should remember to check whether the given relation is a function or not? First, you should check each and every element of set A should be mapped. There should not be any element left out. First point. Second point, each element should have a single mapping only. It should not be multiple mapping, right? So these two things you have to check. If these two things are true, then the relation will become a function, right? If you get a confusion that single element in B has two pre-images, then that is a function only. You don't want to bother about codomain. You don't want to bother about codomain. To check whether the given relation is a function or not, your aim is only on domain. Check every element has a mapping or not. And second point, check every element has a image, single image. It should have a single image. Then that particular relation is called a function, right? Next we will see what is real valued function and real function. From the name itself we can say real valued, in the sense the answers to be real numbers. If the range is real number or any subset of real number, then it is called a real valued function. If the domain is R, real number, or any subset of R, then it is called a real function. If the function is defined on real numbers, then it is called real function. If the range is real number, then it is called real valued function, right? Now let us see some of the standard functions and how their graphs are going to be, right? First one is identity function. What is meant by identity function? Identity means the same number. So the number which maps to itself, right? So it is a function f from real numbers R to R such that y equal to f of x. The f of x value we will denote it by y, and that is the element in the codomain, or else the range we will denote it by y, and the element in the domain we will denote it by x. So f of x equals to x. The element should be mapped to the same element for all x belongs to R. In this case, the domain and the range both are real numbers, and the graph will be a straight line passing through the origin. Obviously, yes or no? Because the element should be mapped to itself. 1 should be plotted to 1, 2, 2, 3, 3. Since I have drawn roughly, it becomes like this. But when you plot it on a graph sheet, you will get a proper straight line passing through origin, because the element is mapped onto itself. So this is called a identity function. Now let us see few more functions. Next, what we are going to see is a constant function. What is meant by a constant function? So the element in a domain is mapped to a particular constant, constantly to that element only. I told such a kind of mapping is a function only. Many elements from domain can be mapped to a single element in a codomain. This is a function only, right? So here every element in the domain is mapped to a particular constant. Such a function is called a constant function. Here the domain is a real number, whereas the range will be a single element, because all the elements are mapped to a single element. Now how the graph of this kind of function will be? It will be a parallel line to x-axis. All the element will be mapped to a particular element. So if you plot it on the graph, you will get a parallel line to x-axis, right? Next is a polynomial function. What is meant by a polynomial function? The function is defined as a polynomial. On looking at this general description, don't get scared. It is just a general notation. If you see the example, it will be easier. A function f from R to R such that y equal to f of x, which is equal to a naught plus a1x plus a2x square plus etc. a n x power n. That these a naught, a1, a2 are constants, coefficients, and n should be a negative, non-negative integer. Now if you see function like x cube minus x square plus 2, these are all examples of polynomial function. If a polynomial is defined as a function, then it is called a polynomial function. When we talk about a polynomial, immediately if you see the next example, x power 2 by 3 plus 5, is this a polynomial function? No, because first of all it should be a polynomial. What is the definition of a polynomial? It should not have a fractional power, right? So x has power 2 by 3. First of all, this is not a polynomial at all. Then how it will become a polynomial function? It won't. So whenever they ask you to check whether the given function is a polynomial function or not, first check for the powers of the variable. First it should be a polynomial, right? We didn't talk about the graph of the polynomial function. Why? Because it depends on the function which is polynomial defined. If it is going to be a cubic polynomial, it can be a graph of any type, like any curve. We have seen how the graph of the cubic polynomial will be. If it is going to be a quadratic polynomial, then it will be a parabola, curve, open upward or open downward. Hope you remember, we discussed in the previous chapter. If it is going to be a cubic polynomial, it can be any curve like this or a curve like this. Yes, hope you remember. So it depends on the polynomial which they define. So that's why it won't have any specific sort of graph. That's why we didn't discuss here, right? So next we are going to see about rational functions. What is meant by rational function? Rational number. What is a rational number? P by Q format. So we should have two functions in the numerator, two functions, one in the numerator and the other in the denominator. If we have such a kind of function, then we will call it as a rational function. See, f of x divided by g of x. We have given few examples. F of x equal to 1 by x minus 3, where 1 is a constant function here and x minus 3 is a polynomial function. If we have two functions, one in numerator and the other one is in the denominator, then we will call such a kind of function as a rational function, where the denominator should not be equal to 0. Yes, hope you understand. Next, what we are going to see is modulus function. What is meant by modulus? It's a function defined from R to R. F of x equals to modulus of x for every x belongs to R. How this modulus functions? Hope you would have come across this symbol modulus. What we will do, if we write a number inside modulus, we will take only the positive value. If we have minus 2 inside modulus, we will take only 2. So in spite of its sign, we will take only the positive value. That's what the function is defined here. It is equal to x for x greater than or equal to 0. In the sense, if the value which you are taking is a positive value, then the answer will be positive only, the same number. If it is less than 0, in the sense if it is going to be negative value, then it is minus x. Why it is minus x? Then only minus into minus it will become again a positive number. For example, if you are going to choose x as minus 2, then the function defined is minus of minus 2. So minus into minus it will become plus 2. So you will get only the positive value. Yes, hope you understood. So the modulus sign is the value which you have, whatever value you have taken in spite of its sign, we will take only the positive values. So how we can define it as a function? If the value which you have chosen is greater than or equal to 0, you will get the same number. If it is going to be less than 0, negative of that, then only you will get a positive number. So when you plot it in the graph, how you will get? You will get a graph like this, because for positive values 1 and a 1 value you will choose, 2, 2, 3, 3 you will plot. So you will get a line like this. But when you are going to the negative numbers, if you are going to take minus 1, then also you are going to plot 1 only. If you are going to take minus 2, then 2, minus 3, 3. So you will get a straight line like this. So the graph of modulus function will look like this. Then what about its domain and range? Domain will be real numbers and range will be of sure it will start from 0 only. We won't get any negative values here. So it is closed at 0 and open at infinity. Since the domain is a real number, it can be any positive integer or positive real number, right? So it is from 0 to infinity. That's why it is open at infinity. So this is called a modulus function. Next, what we are going to see is a signum function. What is a signum function? It is a slight modulation with modulus function. Here the range is going to be 1, 0, minus 1 only. There we got any number, right? Here whatever number you choose, the answer is going to be 1, 0, minus 1 depending on the number what you are going to choose. The number what you are going to choose, if it is going to be a positive number, then it will map to 1 always. If it is going to be equal to 0, it will be mapped to 0. If it is a negative number, it will be mapped to minus 1. It is a combination of constant function and a modulus function, right? Constant function, whatever number you choose, we will be mapping on to a same element in the codomain, right? Here instead of same element, we are going to map it to 1 and minus 1. If it is going to be positive number, we are going to map it to 1. If it is going to be negative number, we are going to map it to minus 1. That's it. So this function is called a signum function. This can be rewritten like this also. Modulus of x divided by x. Why it is modulus of x divided by x? If x is not equal to 0. If the x which you are going to choose is going to be positive number, then modulus of x defines a positive number only. So it will be x. So x and x will get cancelled, you will get 1 as your answer. So that's what it is defined. If the value which you are going to choose is going to be negative, then also the modulus function going to give you only positive value, then x and x will get cancelled, but denominator there will be one minus, so you will get minus 1, right. I will show you with an example. Suppose if you are going to choose x as minus 2, right, I am going to choose x as minus 2. Now what will happen in this function? Modulus of x divided by x, which is equals to modulus of minus 2 divided by minus 2. What is modulus of minus 2? Which is nothing but 2 only, divided by minus 2. So 2 will get cancelled, we got minus 1. So if I choose a negative number, I am ending with minus 1. That is what the signum function defines, right. Now let us see what happens if we choose a positive number. Say I am going to choose x is equals to positive 2. Then what will happen? Modulus of x divided by x will be modulus of 2 divided by 2. Modulus of 2 is nothing but 2 only. So 2 will get cancelled, I will end up with 1. So if I choose x is equals to 2, I am getting answer as 1. So if I choose a positive number greater than 0, you should get 1. If I choose x as minus 2, I am getting minus 1 as my answer. So if you choose a negative number, you will get minus 1. So this signum function can be rewritten like this: modulus of x divided by x when x is not equal to 0. But it is equal to 0 when you have chosen 0. X equal to 0, the value will be 0. Hope you understood, right? Now let us see what will be the domain of signum function as real number. The range is only these three numbers: 1, minus 1 and 0. We are not going to get any other number because the function is defined in such a way. Then how the graph will be? Graph will be like this only, because positive values now we are going to plot it only along 1. If it negative value now we are going to plot it along minus 1. If it is 0, we will plot it here. So the graph will be like this only for the signum function, right? Now let us see the next one. Next is greatest integer function. What is meant by greatest integer function? Oh, this also we have come across in the previous classes. If we write any number inside this symbol, what is the symbol stands for? Greatest integer. We will take the minimal whole number as your value. For example, minimal integer as your value. I am sorry, not whole number, minimal integer as your value. For example, if I write minus 2.3 inside this square brackets, we will call it as a greatest integer symbol. Then we will take minus 2 as my answer. We will avoid the decimal values, we will use this function which is called greatest integer function. So which assumes the value of the greatest integer less than or equal to x. For example, see, if the chosen value is between minus 1 and 0, we will take the answer as minus 1. If the chosen value is from 0 to 1, we will take 0 as your answer. The smallest value we will take. Okay, we will take that value as our answer. So that's what's represented in the graph also. See, if the value is going to lie between 1 and 2, we will take 1 only as your answer till 2, not inclusive of 2. Okay, less than 2, till less than 2, we will take 1 as our answer. When it starts from 2 to 3, not inclusive of 3, exclusive of 3, then we will take 2 as our answer. Same way with the negative numbers also. If you are going to choose values from 0 to minus 1, then we will plot it in minus 1, right. I will show you with a numerical example, then you can understand in a better way. Suppose what will be the answer for the greatest integer of minus 2.3? This will be minus 2. Even if it is going to be minus 2.8, then also it is going to be minus 2. Normally rounding off, what we will do? Rounding off, we will round off to the next integer by looking at the decimal value. If it is 0.5 or more than 5, what we will do? We will move on to the next integer. But the greatest integer function is not like that. We will move on to the less number. Minus 2.3 is minus 2. Minus 2.8 is also minus 2 till we reach 3. So what is minus 4.5? This is minus 4 only. The same way with the positive values. What is greatest integer of 5.6? It is 5. 5 is the greatest integer here. Similarly, what is the greatest integer of 3.2? Is 3. Right? This is called greatest integer function. That's what the definition says. If it is going to be minus 1 less than or equal to x less than 0, then the value will be minus 1. From minus 1 to 0, the value will be minus 1 only. So if you take any x value between minus 1 to 0, we will plot under minus 1 only. That's why they have drawn line like this. If you are going to take any value between 0 to 1, any value between 0 to 1, it will be 0 only. We will be plotting here only. If you are going to take any value between 1 and 2, we will be plotting in 1 only. Any value between 1 and 2, we will be plotting in 1 only. That's why all the plottings will come here. Right? 1. If you take any value between 1 and 2, we will be plotting here only. So that's why they have drawn like this, but not inclusive of 2. When it starts with 2, we will move on to 2. 2 to 3 if you want to take any values from 2. From 2 if you want to take any values less than 3, then we will plot under 2 only. All the plottings in between these values we will plot like this. So this will come like a line like this, right? So that's why they have given graph of greatest integer like this. Hope you understood, right? So if you see the numerical examples, you will get better clarity. So here if you see, the domain will be real number and the range is z. Right? So in spite of the decimal values, you take the whole number. You remember like that. So what is greatest integer function? In spite of the decimal values, we will take the whole numbers as your actual value. Right? That is greatest integer function. So in today's class we learnt what is meant by a function. Then we have seen few standard functions and their graphs. Identity function, then constant function, polynomial function, rational functions, then modulus function, signum function, and at last greatest integer function, right? So kindly go through all the definition of the functions once again, so that you will get a better clarity. Now with this we will wind up today's class, and homework will be exercise 2.3 question number 1, 3 and 4. All these 3 questions you can do it by your own. It's a simple question. If you see the first question, they asked you to find which one is a function. So you can do it by drawing arrow diagram. I have given you a clear explanation about what is meant by a function. So I asked you to remember 2-3 points. So draw the arrow diagram for these 3 questions and check whether it satisfies all the conditions which I told you. If it satisfies, then it will become a function. If it does not satisfy, it is not a function. So you can very well do the first question. Second question we will discuss in next class. Third question, they have defined a function. They asked you to write down the values. It is simple, which we have done in polynomials. F of 0 means in the place of x you have to put 0 and find the value. So you can do it. Fourth question also, they have defined you a function. They asked you to find different values. It's a relation between centigrade and Celsius and Fahrenheit. So T of 0 means in the place of C you have to put 0, the same way. Fourth subdivision is the value of C where T of C is 212. In the sense Y value is given, you need to find what is C. So 9C divided by 5 plus 32 equals to 212 you have to take and find what is your C value. So hope you can do these 3 problems as homework. Complete the homework and post it in the group before evening, and we will discuss the remaining 2 problems and few more standard functions in the next class. Thank you, students.